Initial designs for Pegasus were created through a collaboration between real spacecraft engineers and the art department on the production. Spacecraft designers from EADS Astrium then helped us turn these rough drawings into engineering designs that our animators could work with.
Hi, Pegasus Commander Tom Kirby here. Halfway to Mars and time for our regular Q&A. This week's topic is our interplanetary home, Pegasus. I've got the email address on the screen here, so keep those questions coming. Okay, first question is, how big is Pegasus? Well, you could fit in 12 football fields end to end, so pretty big.
But it was science that dictated the look of Pegasus, the distances it would have to travel, and the environments it was going to in the story, flying past the sun and crashing into the top of planetary atmospheres. But above everything else, Pegasus had to keep the crew healthy for the 6 years that this mission would take.
Well, space is a kind of naturally pretty hostile environment for human beings. So the first thing you need is shelter. You need shelter from radiation, shelter from the vacuum, shelter from the temperature extremes. That's the first thing. Then beyond that, you've got to have food, you've got to have water, you've got to have power to run things, and you've got to have an environment which is kind of keeps you healthy and keeps you sane. Pretty much the same sort of things you need on Earth, but obviously it's much more difficult to provide in space.
This is a mission like no other. You're not packing just for a drive up the motorway, you're packing for an expedition of 6 years in duration where you need to take everything with you, and it's got to be right there in the vehicle before you go, and it's got to last for all that time. If you don't, you're going to run out of food or fuel or power or light or heat, and your mission's going to be over. That in itself represents a massive technological challenge.
Traditionally, spacemen have eaten things like this. Everybody knows it's either freeze-dried or it's some form of rehydratable mixture. This is apple puree, or in the early days of Apollo, it was all out of tubes, a bit like toothpaste. That will keep people alive, but it's not very stimulating. And one of the important things for a long-duration space mission, if you're going to be away for years and years and years, is that you try and keep the crew happy. And one of the ways to keep people happy is to give them nice, interesting food. So obviously, the Pegasus mission is going to have fuel dumps and food dumps along the way, so they can pick up food there. But I think in order to keep them happy, to keep them stimulated, they're going to need to grow some of their own food actually on board the spacecraft.
And how about the food, Nina? Is it fresh or frozen?
A bit of both, actually.
One important thing will be the recycling of water, though. They're going to have water to drink, water to wash with. It's going to be very, very difficult to transport enough water for the astronauts to use.
Yes, viewers, I've been drinking his urine for the last 6 months.
According to my calculations, they're going to need to take about 60 tons of dried food, 300 tons of water, something of the order of 150 tons of oxygen in order to keep them alive throughout the mission.
We take a lot for granted on Earth, and we have more than just air to breathe. We have warmth, we have food, we have water. We also have quite significant protection from radiation. In the atmosphere itself, but also in the magnetic field that surrounds the Earth. Once you get out beyond the Earth's magnetic field, you're open to much more damage from radiation from a number of sources, and you need to protect your crews against that. And how you do that is really a big problem. The longer they're out there, the more radiation they're exposed to. The more radiation they're exposed to, the more tissue damage they're going to get.
There's two main sources of radiation. There's solar radiation, the radiation that comes from the sun, and what we call cosmic rays, which originate outside the solar system.
Every 22 years the sun becomes very active and throws out a lot of radiation. But even during relatively quiet periods, our nearest star can still hurl out dangerous levels of charged particles.
If you're on a spacecraft at that time, that's a very unhealthy time to be there, because the radiation is quite capable of killing you. So if you're on an interplanetary mission, such as on Pegasus, you've either got to have some sort of shielding, or you have to have what they call a storm cellar, an area which is specially shielded. And when the radiation alarm goes off, everybody just drops what they're doing and bundles inside there for the duration of the solar event.
But there's one place that they are going which is potentially even more deadly.
Jupiter has a very strong magnetic field which allows it to trap charged particles, so the space surrounding Jupiter is very, very high in radiation, and Io, where the Pegasus astronauts are going, lies within that radiation field. So they're going to have good radiation shielding to protect them when they go to Io. Human beings evolved on the surface of the Earth in a gravity field of what we call 1G, one Earth gravity. And many things about the way our bodies work are sort of related to gravity. On Earth, we're using our muscles all the time. That keeps them strong. And so we can walk around. On the other hand, if you lie in bed for 6 months and then try and get up and walk around, that's much more difficult. And so on Pegasus, the astronauts will be flying through space for long periods of time. And if you don't provide any countermeasures, or they don't do any exercise, their muscles will start to waste because they don't need to be that strong.
One of the things you could do to try and keep your crews well when they're on their way to Mars or wherever you want to take them on your expedition is to take your own gravity with you, in the same way that we take our own light and heat and water and food with us at the moment, to take the gravity that they've left behind.
You can see here these rotating modules which provide us with some gravity to help keep us in shape. This is 0.5 G to be precise, which is half Earth gravity. And here we have Zoe Lessard making up for the time she spends in 0 G by exercising 3 hours a day. As Zoe will tell you, 3 hours a day keeps the muscles and bones from wasting away. Isn't that right, Zoe?
Yes, that's right.
All right, let's take a look in Zoe's sleeping module.
Temperature is a problem in space, because if you just think of a spacecraft such as maybe the International Space Station in Earth orbit, one side of it is exposed to the sun, and the sun's rays will heat that up to about maybe plus 250 degrees centigrade, so pretty hot. The other side of it is in complete dark, it's in eclipse. It can just see, if you like, the inky black void of space. And so that gets very cold. That goes down to about minus 150 degrees centigrade. So you see, even in Earth orbit, you've got a sort of 300-400 degree temperature range across one spacecraft. The same applies to a spacecraft such as Pegasus, except that Pegasus is designed to travel, very, very close to the sun, so it's going to get much, much hotter when it's going in towards Venus. And at the same time, it's designed also to travel to the outer solar system, where there will be almost no heating by the sun, and the problem will then be keeping the spacecraft warm.
And the key to keeping the temperatures comfortable on Pegasus for the whole mission is power. Power to cool things down when they get too hot, and heat things up when they get cold.
Most of the spacecraft we use in Earth orbit use solar cells. You take sunlight and turn it into electricity. That's pretty good while you're close to the sun and if you don't need too much power. But the spacecraft like Pegasus is going way, way out in the solar system. The sun will be almost just a dot, so you can't use solar power. So you really have no option but to go for some form of nuclear power source, nuclear fission possibly, or, given that this is further in the future, a nuclear fusion power source. The advantage of that is if you've got working nuclear fusion, you should have no shortage of power. Power is always a good thing to have.
Putting all these requirements together, a design for Pegasus emerged. This leviathan of a ship was big enough to carry enough food, water and oxygen to sustain a crew of 5 for 6 years, the recycling systems to keep their environment habitable, a centrifuge system to simulate gravity, and the power generators to support all these systems. Inspired by the need to do a job and built in workshops across the world and by digital artists in the UK, our spacecraft was born.